like pretty much everything we've ever done in this class. As soon as it seems like, wow, this isn't too bad, there's always more. So here we go, Billy, I can't remember his last name, but wait, there's more. Just like every good infomercial, there is definitely more to Pivner. So what I want to talk about next is the N in Pivnerd. The N in Pivnerd is equal to the moles. We've used moles a lot, and as you can read, we can apply a lot of what we have done in other chapters to what we will now do in chapter 10. Namely, we will do these few things. We will apply the ideas of gram to mole conversions. That's the simple part. The idea of limiting reactants, that sort of steps it up. And gas forming chemical reactions to gas laws. So really all three of these eventually will combine with Pivnert to help us find N, and then we can do gas laws based on that. These can get pretty long to do, but they're not like the hardest problems. You just have to do them step by step and work through them. And a few people enjoy these because they are, medium difficulty, a medium investment in time, and when you get them right, you feel pretty good about yourself. All right, so here we go. Here's our first example, and this is just the easy ones when you just have to convert some grams to moles. And I believe I already did a problem like this in the last video, but here we go. What is the pressure inside a 2-liter vessel if we have 28 grams of carbon dioxide at a temperature of 350 Kelvin? So in each one of these examples, I'm just going to have the steps that we're going to follow right here. So the first thing we have to do is convert grams of CO2 to moles. So we just take our given. Again, I'm writing on a screen with my finger that's a little bit tricky, so hopefully it looks okay. But if 28 grams of CO2, you want to end up with moles. So you just need to know the molar mass or grams of CO2. And that's 44 grams per every 1 mole. All right, so you just take 28 and divide it by 44. And I didn't bring a calculator. Let's see, that is 1420 seconds. So, I don't know, it's roughly 2/3. I'm going to say, and I could be wrong, I'm just going to say it's like 0.68 moles. Now, I don't know that number. You calculate it. I'm just going to go with 0.68 moles. So once we've done step 1, we can move to step 2, where P equals nRT over V. So simply, we do our molar conversions and then Pivnerd. So it's just one extra step. So our pressure will be equal to N, which is my number I estimated here, 0.68 moles. Then R is 0.0821. And then our T is 350. No conversion needed because I'm already in Kelvin. And then I'm going to divide that by my volume, which is 2. Now I'm not going to calculate this. You're welcome to go ahead and type that into your calculator. And you would have your answer fairly simply. Now that you have done 1 or 2 of those sample problems, let's move on to the next part and step the difficulty up a little bit. So, what if there are more than 1 gases in the container? I don't know, that's a terrible sentence, but whatever. It's pretty simple. We find the total moles of everything in the vessel, and then we Pivnerd it. You'll see this in another slide. But N doesn't care about what it is or if it's more than one thing or what it came from something that wasn't a gas or anything like that. It just cares that it's moles of gas. So here we go. A practice problem. If a 4-liter container contains 10 grams of O2, 10 grams of H2, and 25 grams of water, and I should have put this in here, we're going to say that's water vapor. That matters a lot because typically when we think of water, we think of it as a liquid. But in these problems will be pretty clear so that you have an idea of whether you need to use it in PivNert or not. Because if it says liquid water, then I don't need to worry about it. All right, so here we go. The steps are to first convert all of your masses to moles. So we did that in the last step. We essentially just divide them by their molar masses. Number two, you add all the moles together. And then in parentheses is like what I said. PivNert does not, whatever, that should be whatever, apostrophe, doesn't care about the identity of the gas or gases. It just cares about the total moles of gas in the container. So we can do whatever we feel like. We'll just add them all together. And number three, we'll solve for pressure by using PivNert. So convert all masses to moles. So if I have 10 grams, I'll do this over here. 10 grams of O2, divide that by 32. 10 grams of H2, I'll divide that by 2, because that's their molar masses. And then 25 grams divided by 18. Each one of these will give me an answer. And man, I really, again, don't feel like getting my calculator. So I'm going to say that this is roughly, so 5/16, and they, whatever, I don't know, it's around 0.35. Now I'm making these numbers up. This one's 5 for sure, and 25/18 is probably around 1.35. I don't know. I'm just making those up. Okay, now once we have all of their moles, we add all of these numbers. Now please do your own calculations, but we could add these together. I have 5 plus 1.35 plus 0.35. That is 6.7 moles with my rounding math. All right, and now that we have the N value, we're ready to PivNert it once again. So we don't care that there's more than one gas. We just find the amount of moles and we're off to the races. P equals, and once again, use the number that really was there, 6.7. That's our N. Then 0.0821. And then our T is 298 Kelvin. And our volume here is a 4-liter container. So you can go ahead and plug that in and get your answer as well. Please do the next example.